Assalamualaikum and hi everyone. My name is Nurul Natasha binti Muhammad Saad and my student ID is 2021127077. So first of all, we will start with introduction. So what is energy? Energy basically a resource that can be classified as renewable or non-renewable based on whether it can replace itself at the rate it is used up or whether it has a finite supply. Timber, wind, and solar power are examples of renewable resources, whereas coal and natural gas are examples of non-renewable resources.
Assalamualaikum and hi everyone. My name is Nurul Hanan binti Muhammad Muhajidin. I will continue with non-renewable energy. There are two parts in this topic. I will present about fossil fuel, which are coal, oil and natural gas. The sources of fossil fuel can be found on the land, which are coal, while oil and natural gas usually found in the sea. Next, the formation of coal. In marshes and wetlands, dead plant material including ferns, shrubs, vines, trees and algae builds up on the surface. Bacteria initially break down the organic material producing carbon dioxide and methane. The plant material is buried and is no longer exposed to the atmosphere. After then, the material starts to break down due to anaerobic microorganisms. Long-term burial and accumulation can result in many of partially decomposed plant material known as peat. When peat is completely buried, the growing pressure squeezes out water and other compounds, forming lignite, the lowest grade of coal. This low-grade lignite coal is turned into higher quality black coals by continued burying, which result in increased pressures and temperatures. Lignite is converted into subbituminous coal, then bituminous coal, and lastly high-quality anthracite coal. The quantity of water and other chemicals in the coal reduces as this conversion occurs, and the coal gets denser. This is accompanied by an increase in carbon content. There are three types of coal, which are lignite, bituminous, and anthracite. Oil and natural gas formation. Tiny marine plants and animals died were buried on the ocean floor. Over time, the marine plants and animals were covered by layers of silt and sand. Over millions of years, the remains were buried deeper and deeper. The enormous heat and pressure turned the remains into oil and natural gas. Today, we drill down through layers of sand, silt and rock to reach the rock formation that contain oil and natural gas deposit. The reason why natural gas and oil usually found in the same place because natural gas is lighter. It is often found on the top of the oil. The uses of coal to generate electricity. Coal is used in coal-fired power plants to produce steam, which then spin turbines to produce electricity. Many companies and industries have their own power plants, some of which use coal to produce energy for internal consumption. In the industry, coal and its byproducts are used in several industries. In order to generate heat, the paper and concrete sectors both use a lot of coal. Coal is used by the steel industry to smelt iron ore into iron, which is then used to create steel that has the strength and at the same time flexibility that required for bridge buildings and automobile. The uses of petroleum. Gasoline used as motor gasoline for retail sale at fueling station. Next, distillate fuel oil, which are diesel fuel and heating oil. Diesel fuel is used in the diesel engines of heavy construction equipment, trucks, buses, tractors, boats, trains, some automobiles and electricity generators, while heating oil is used in boilers and furnaces for heating homes and buildings, for industrial heating and for producing electricity in power plants. Lastly, hydrocarbon gas liquid, which are ethane, produce plastics, antifreeze and detergents. Propane produce fuel for heating, cooking and drying and also plastics. And butanes produce motor gasoline, plastic, synthetic rubber and lighter fuel. Natural gasoline produce motor gasoline, ethanol, denaturant and solvent. Lastly, refinery olefin produce plastic, artificial rubber, paints and solvent and also resins. Next, the commercial sector uses natural gas to heat buildings and water, to operate refrigeration and cooling equipment, to cook, to dry clothes, to provide outdoor lighting and also as a fuel in combined heat and power system.
Next, we will continue with nuclear power. Uranium was discovered in 1789 by Martin Klaproth, a German chemist, and named after the planet Uranus. The science of atomic radiation, atomic change, and nuclear fission was developed from 1895 to 1945, much of it in the last 6 of those years. Over 1939 to 45, most development was focused in the atomic bomb. From 1945, attention was given to harnessing the energy in a controlled fashion for naval propulsion and for making electricity. Did you know, since 1956, the prime focus has been on the technological evolution of reliable nuclear power plants? As you can see, this is the picture of nuclear power plants. Next, we will go to nuclear reaction. Nuclear reactions deal with interactions between the nuclei of atoms, including of nuclear fission and nuclear fusion. Both fission and fusion processes deal with matter and energy. Fission is the process of splitting of a nucleus into two daughter nuclei, leading to energy being released. Fusion is the process of two parent nuclei fused into one daughter nucleus, leading to energy being released. Now, we will go through fission reaction. A classic example of a fission reaction is that of U235. So this is basically the fission reaction equation. In this example, a stray neutron strikes an atom of U235. It absorbs the neutron and becomes an unstable atom of U236. It then undergoes fission. These neutrons can strike other U235 atoms to initiate their fission. Now, fusion reaction. A classic example of a fusion reaction is that of deuterium heavy hydrogen and tritium, which is converted to helium and release energy.
Assalamualaikum, my name is Izahana, student ID 2021131359. Today I would like to continue video presentation on renewable energy. As you know, renewable energy consists of three parts: solar energy, wind energy, and hydro energy. Renewable energy is energy derived from natural sources that are replenished naturally on a human timescales. In addition, it exists over wide geographical areas. The examples of renewable energy is sunlight, wind, rain, tides, waves, and geothermal heats. Why is renewable energy is important? Firstly, it has environmental benefits. Compared with conventional energy technologies, renewable energy techniques are clean energy sources which significantly reduce the effect. Secondly, energy for our generation. It is because this renewable energy will not run out. Thirdly, jobs and the economy. And lastly, energy security. In my parts, I will explain more about solar energy. Solar energy comes from radiant light and heat from the sun. With a solar constant of 1.366 kilowatt over m square, the famous technologies that have been used are solar heating, solar photovoltaics, solar thermal electricity, and solar architecture. Moreover, depending on how they capture, transform, and distribute solar energy, solar technologies may be divided into two categories. The methods are passive solar and active solar. Passive solar are include orienting a building to the sun, selecting material with favorable thermal mass or light dispersing properties, and designing spaces that naturally circulate air. Meanwhile, active solar only PV panels and solar thermal collectors. The next subtopic is solar power. Solar power in conversion of sunlight into electricity. The conversion either directly using photovoltaics (PV) or indirectly using concentrated solar power (CSP). Photovoltaics is convert light into electric using the photoelectric effect. Meanwhile, concentrated solar power system use lenses or mirrors and tracking systems to focus a large area of sunlight. There are two types of solar energy that are widely known: photovoltaics and solar thermal. Photovoltaics is generating electrical power by converting solar radiation into direct current DC electricity using semiconductors that exhibit the photovoltaic effect. Meanwhile, solar thermal is to generate thermal energy or electrical energy for use in industry and also in a residential and commercial sectors. We go through to the photovoltaic system, that a system of parts intended to provide useful electricity for various users, utilizing the sun as the power source. Next, photovoltaic array that multiple photovoltaic modules, solar panels, to convert solar radiation into usable direct current DC electricity. There are the characteristics of photovoltaics, which are an array of PV modules, one or more inverters, and a racking system that supports the PV modules. There are also comes with electrical wiring and interconnections and mounting systems. There are two types of photovoltaic system. The standalone system that need one or more PV modules, conductors, electrical components, and loads. Next, the grid-connected system, that the PV power system that is connected to the utility grid. The application of standalone system is absence of access to the public grid. Meanwhile, grid system is directly connected with the public utility grid. Lastly, the differences in storage terms, where standalone system uses solar batteries to store the DC electricity produced, and the grid-connected system act like a battery with an unlimited storage capacity. The next slide is the figure on how the process of the standalone system and grid-connected system. As we can see, the grid-connected system are more compatible. There are a few advantages above grid-connected system. Firstly, reduce the power bill, as it is possible to sell surplus electricity produced to the local electricity supplier. Secondly, comparatively easier to install, as they do not require a battery system. Thirdly, the grid-connected system is effective utilization of generated power because there are no storage losses is involved. Forwarded to the next type of solar energy, which is solar thermal. The solar thermal collectors are classified by the United States Energy Information Administration as low, medium, or high temperature collectors. Let me go through one by one. To start with, the low temperature collectors is flat plates, generally used to the heat swimming pools. Next, medium temperature collectors are also usually flat plates, but are used for heating water for residential and commercial use. Lastly, high temperature collectors concentrate sunlight using mirror or lenses and are generally used for fulfilling heat requirements in industries and for electrical power production.
Assalamualaikum, my name is Nur Syahidatul Syahira binti Basili. My student ID is 2021105173. I'm from AS12050. So today I will explain about non-renewable energy. Wind power is the conversion of wind energy into a useful form of energy, such as making wind turbine to make electrical power, windmill for mechanical power, wind pumps for water pumping or drainage, or sails to propel ships. The term wind energy or wind power describes the process by which the wind is used to generate mechanical power or electricity. Wind turbines convert the kinetic energy into the wind into mechanical power. This mechanical power can be used for specific tasks, such as grinding grain or pumping water, or a generator can convert this mechanical power into electricity to power homes, business, school, and the like. Wind turbine like aircraft propeller blades turn in the moving air and power an electric generator that supplies an electric current. Simply stated, a wind turbine is the opposite of a fan. Instead of using electricity to make the wind, like a fan, wind turbine use wind to make electricity. The wind turns the blade which spin a shaft which connect to a generator and make electricity. Next is type of winds. There are two types of winds. The first one is horizontal axis. The axis of rotation is parallel to the ground. The blades are faced in the direction of the wind and spin around a horizontal axis when pushed by the wind. Thus, the turbine can convert the wind's kinetic energy into electrical energy. And the next is vertical axis. The blades spin parallel to the ground so that they can operate anywhere regardless the wind direction. Other than that, we have hydropower. Hydropower has been one of the main sources of power for 500 years and more, and blossomed with the invention of the overshoot wheel, which efficiently converted the power of falling water to useful mechanical energy. Hydropower converts the natural flow of water into electricity to light our homes and power other industries. The energy is produced by the fall of water turning the blades of a turbine. The turbine is connected to a generator that converts the energy into electricity. Hydropower is actually generated quite simply. As long as the movement of the water, it is possible to generate power because water is 500 times as dense as air. Even a slow stream will generate power as a result. When the water moves through a dam or a confined space, it begins to rush faster as a result of more water going through a smaller space. When it does this, it sends turbine that then help to power a generator. The generator then sends power into batteries and converts in order to send power out or advantage of hydropower. Firstly, the power is usually continuously available on demand. Next, given a reasonable heat, it is a concentrated energy source. The energy available is predictable. No fuel and limited maintenance are required, so running costs are low. Compared to diesel power and in many cases import, are displaced to the benefit of the local economy. It is a long-lasting and robust technology. System can last for 50 years or more without major new investment. For the disadvantage of hydropower, first, it is a site-specific technology and sites that are suited to the harnessing of water power and are also close to a location where the power can be economically exploited are not very common. There is always a maximum useful power output available from a given hydropower site, which limits the level of expansion of activities which make use of the power. River flow often varies considerably with the seasons, especially where there are monsoon-type climates, and this can limit the farm power output to quite a small fraction of the possible peak output. Lack of familiarity with the technology and how to apply it inhibits the exploitation of hydro resources in some areas. There are two types of water turbine, which are reaction and impulse. The example of reaction turbine is water wheel, Pelton, Turgot, and Archimedes screw turbines. For the impulse, the examples are French's Poplar, Tyson, and Gorlock.
In conclusion, renewable energy is energy produced from sources like the sun and wind that are naturally replenished and do not run out. Renewable energy can be used for electricity generation, space and water heating and cooling, and transportation, while non-renewable energy is a source of energy that will eventually run out. Most sources of non-renewable energy are fossil fuels such as coal, gas, and oil. That's all from me, and that's all from us. Thank you.